Hey guys, David here and welcome to another Dark Art Guitars video. Today it is time to talk about the CNC again. It's been over a year since I built it and I've made over a dozen guitars on it and used it a whole bunch. Overall, I'm super happy with it, but of course, just like any DIY project, there are a couple little niggles and things that need to be fixed. And I also want to upgrade a few things about it. So thinking about all the little small things that I never bothered to fix, I came up with this list. And good thing that the board ended here, otherwise I might have come up with more. This should be more than enough things to figure out, and some of the ones at the bottom, they might be a separate video. But I think we can get started on the top here. Those are much simpler things to do, and the first one on the list is updating Masso. The Masso controller behind me, I haven't updated it since, and a couple of software updates have come out, which fix some bugs that annoy me, as well as add some new functionality that could be really useful, so I just haven't gotten around to that. And at the same time, I'm going to look into the USB port. It's a bit of a flaky connection. Most of the time it works, but every once in a while the USB stick disconnects. And I'm pretty sure it's not the stick itself, but the port. So maybe there's a loose pin in there or something. Now, before I do the actual update, I do want to save its configuration. I believe that should be somewhere here in its setup. Yes, save and load settings. Save to file. Alright, so apparently those settings should have been saved to a file on the USB drive now. So I'm gonna go check that out. Alright, so reading the documentation for the newest version, which is actually 5.13, and I'm all the way back at 5.07. It recommends to save as a printable file as well. This one is human readable, and this saving to file is just like the file the machine can read. But apparently in 5.13 they switched this file type, so they recommend just as a backup doing a human readable, so you can manually change all the settings back in case something goes wrong. But ideally, like, all the settings should remain in there when you update it. So now downloaded the newest software, and I believe to install it we just need to reboot it and then we can install it. Here we go. Alright, here we go. This should be the newest software. Yeah, 5.13. Looks like at least these settings have transferred. Let's see about the tool changer. Yes, all of that is in here as well. So I'm assuming that the rest also transferred. With that, we have the first box that we can tick off. Alright, so I tried the USB port down here, and doesn't really seem to be much that I can change here that is loose or not. It's all soldered on and the cables seem fine. But it is just routed up here, and then there's a USB port here on the controller itself. So I've just added in the USB port, the USB stick here, and I'm gonna see if this clears. If it clears, I'll probably just leave it like this for now. Maybe I'll get a replacement eventually, but I used the Wi-Fi feature to get the software on here anyhow, so I don't really ever unplug this USB stick, so it's kind of fine if it is in here instead of on the outside. Yeah, it appears to clear, so let's leave it like that for now. Well, technically it didn't fix it, but I fixed the USB stick disconnecting issue, so let's color this in, but maybe add it in brackets. Now the next point about modifying the post processor is something I've actually done before. If you go into your post library and look at your post, you can copy it, for example, and then click on edit, and this will bring up the code essentially that runs inside of Fusion 360 that generates your G code. There is a lot of stuff happening here, but it is fairly easy to understand if you have some coding knowledge. I've used this before where I added some custom logic whenever it calls the tool changer to get around the fact that you cannot do scripting on Masso. Well, you couldn't then at all, and now it costs $750. But the way I get around it is just to do my scripting inside of the post-processor. Now, what I want to actually add now is whenever a program is done, I do two things every single time without fault. I move the Z-axis all the way to the top, and I move the dust tube back all the way to the top. So instead of having to manually do that every time after the program is done, I can just automate it and add it in here. Now the function that is called for the very end of the G code is the onClose. It is at the very bottom of the file, and I've just added a couple of lines in here. First I put a comment just to see more easily in the G code where I added something, and then I added the same line I'm also using in the tool changer, G53, which is absolute machine coordinates, and G0, which is rapids, A0, which moves the dust tube all the way to the top. And then the same thing for Z. Z0 for me is all the way to the top, and I go negative. You definitely want to be very careful what you put here for Z. If Z0 for you is all the way at the bottom, then you make sure not to add it like that. And then I'm using this current section.wcs, and that basically says which work coordinate system you were in before, and I set it back to that just so that if I do some probing afterwards, I make sure that I am in the right work coordinate system. And then after that, this was already here, is the m.format 30, which writes the M30 output, and that's how I know that this is the place where the very end of the program is, because the M30 is always the very end. So these couple of lines should hopefully mean that all programs that I post from now on will automatically have the spindle and the dust tube move up. Now let's very quickly try this. I'm gonna just post something here that's a part from the guitar. It doesn't really matter. I have the right post process selected here. I'm gonna post, and let's see if it added it to the thing. And here now at the very end it says custom end logic here. That's my comment. G53, G0, A0, C0, and then back to G54, and then M30. So that worked. Now the next point I want to look at, I'm actually jumping a bit ahead, is the y-axis backlash question mark. And the reason why I have this point on here is when making these headpieces, I made a video about them and I recently made some more. There is a very distinct line here exactly where the y-axis changes direction. Now it is very faint, but it does take a bit more to sand down to just the regular machining marks. And if the y-axis had just a little bit of backlash, it could show, for example, in this way. Now, this is small enough that on woodworking I will never notice this, but I want to know whether there is some backlash, and if, then I can maybe fix it. And when I next time make some aluminum parts, it will turn out nicer. So to figure out whether there's backlash, I'm gonna go ahead and use a dial indicator. Now let's find a good spot to actually read it from. So I now have the tip of the dial indicator on the spindle body, and make sure that it's touching nice and flat to reduce any cosine error. And then we can move back and forth and see if there is any kind of distance lost when we change directions. Might be a bit small to see. So I'm moving 0.1 millimeters now in y-axis. So I moved a couple times forwards now, and I'm gonna move backwards and see if I move backwards by exactly 0.1 millimeters or less. Well, if there is any backlash in the y-axis, then it is too small for this dial indicator to notice. Now, theoretically, this goes down to roughly 1/100th of a millimeter, so 10 micron I'm going to put in a slightly more precise one that I have and see if we can see something on there. So on this indicator here, one tick mark instead of 10 microns is just 2 microns. So by just moving 0.1 millimeters as I was moving before, the needle moved by half a rotation. So I'm going to go down in step size even more and see if we can detect something now. This is behaving a bit weird. The steps are quite irregular. I'm not sure if that is something about like the step translation and the servo motors, or if it is just this very cheap dial indicator not behaving very well. But by moving just 10 microns at a time, I definitely can hear a difference whenever I change direction. It kind of sounds like there's almost a bit of a clonk, if you know what I mean, instead of just a small zip sound. So this tells me that something is loose somewhere and is changing. But this should hopefully be addressed in the next spot, which is tightening the belts and all of the bolts. Assuming that this is just a loose bolt somewhere and something that is not quite tight. But inconclusive results so far, I would say. Little bit of an update here. Now, apologies for going handheld here, but there's absolutely no way I can show you back here with a tripod. So I took off the cover plate here that covers up the belts, which transmits the power from the motor to the lead screw here. And I'm actually quite happy to see that all the bolts are still tight, and the belt also is still as tight as I remember making it. But looking very closely here, I think see the reason for the backlash phenomenon that I can see, and as well as the different sound. Now let me show you a bit closer here the output of the servo motor shaft. Now I hope I'm not making you guys too sick here with this tricky footage, but I'm gonna just do some couple steps back and forth again like before. Now this almost looks a bit like it is trying to kind of avoid backlash or something, but it's kind of weird why it does that. I'm gonna have to look up maybe the servo tuning or something. I honestly don't know. I'll have to investigate exactly what is causing that. It's definitely something in the servo, and it doesn't seem to be kind of an accident. It seems to be that something it's doing intentionally. Now I did go ahead and investigate the y-axis servo issue a bit further, and I hooked up the computer to the servo drives and looked at the built-in oscilloscope, and I was able to see that while usually moving around the position following error is very small, just around like 2 steps or something, whenever there's a direction change, there's this huge spike. Now, I still don't know why this spike exists, but it definitely explains the kind of jerking motion that we saw when looking very close, and well, the effect it has on the part in the end. Now, looking at the servo parameters, I couldn't immediately find something that means something to me, and I tried to reach out to Leadshine. However, I did not get any answer yet. So if any of you have more experience with servo tuning, please do leave a comment down below or reach out to me in some way. I would love to get this issue figured out, but for now there's not really much that I can do about it. Something seems to be off, maybe some parameter that is set wrong or something. Maybe there is some sort of backlash compensation that is enabled somewhere, but I couldn't find it. So we didn't finish it, but we did start it, so I'm gonna half color it in. About 2 weeks have passed since we last talked, and you just saw me remove the spindle here, and that is to get started on this next point, getting the spindle serviced. That is off back to Spinogy. It had a bit of a vibration issue. I'm going to talk more about what exactly was the issue when I know what the issue was and when I get it back. So for now, I took off the spindle, and the next point on the list is investigating the Z-crunch. And what I mean by that is that there's just a bit of a funny noise at certain spots moving the Z-axis up and down. Now, a while back, I had the ball screw essentially blow up. I was using a fairly cheap one, so I replaced that. It sounded a bit similar, but a lot worse when the ball screw blew up. So I just want to make sure that everything is good and it's not starting to disintegrate again. Now it's not making that noise anymore that I heard before. It wasn't always making that, so it's not that surprising, but I can feel some slightly irregular vibrations moving up and down, but it's really hard to tell anything. So I'm gonna take this plate off anyhow, so I can drill some slightly offset holes for the spindle. I'll talk more about that later as well. So then I can feel out by hand if anything is amiss with the ball screw. Can't necessarily feel anything directly wrong with it, though if I had to guess, I would say it's probably just that some dirt got in it. Everything here is very dirty, and the seals here at the top are not all that substantial, so maybe I'll take it off and see if I can clean it out, and maybe that'll help. So what you just witnessed here is my absolutely ingenious foresight for how to grease the various things on this machine. In other words, I did not put any foresight into that. So in order to grease this bearing here, I need to remove the bottom of this bearing block so it doesn't, so it clears. I also had it turned the way that it was facing the rail, so I had to take off the mount here at the top. To take off the mount, I had to take off the pulley. And well, all of that. Now I put some grease through there, flushed out the old grease, just had it shoot at the top. This is clearly not properly like fully sealed or anything. Quite a bit of dirt came out as well. I cleaned off everything as good as I can. It feels quite a bit smoother now. Now, like it is right now, that will just happen again. But I guess that'll just have to be a, I don't know, biannual maintenance item or something. I don't really have a better solution right now. It's really hard to properly enclose the Z-axis here. So I think I'm just gonna bolt it back together for now, leave the grease port at the very least on this side. I'll still have to remove a whole bunch of stuff, but one fewer thing than before. And then that'll be it for now. So since I screwed it in the wrong way first, I decided to take off the whole thing anyhow. So I cut away a bit of a clearance, so I can at least attach a grease nipple here without having to remove this. Still need to take the spindle plate off in order to access this grease nipple, but at least that is now the only thing. Now, speaking of grease nipples, I should also grease these carriages, but they have a different style of grease nipple that I don't think my gun is directly compatible with. So let's see how big of a mess we can make trying to shove some grease in there anyhow. Yeah, no, I don't think that's gonna work. I won't be able to get a good enough seal to overcome the pressure of the ball that's keeping it closed. And in case you're wondering how I greased them the first time around, the answer is I didn't. I just trusted that the factory put enough in there. So you saw me remove these old tool holders here, and the reason for that is, for one, that I've lowered the spindle now by about 15 millimeters, so I do no longer need this offset. The reason why I had it before was because the spindle couldn't reach low enough to have it flush. So these new ones that I printed here are just flat. This means that the whole tool holders will sit a little bit lower, and that means that the dust shoe is not brushing against them anymore, which caused a lot of dust to settle on them, which is not good. So that's quite an improvement. And while I'm at it, I also calculated that by squeezing them together a little bit closer, I can actually fit one more tool holder. Before I just had 10. 10 was a nice round number and it fit, so that's what I chose. And they were already fairly close, but there's just a little bit of extra space that I could squeeze out to get one more, and I'd like 10 more open spots, so I will take any spot that I can get here. So I designed up these new plates here, 3D printed just like the other ones. It's plenty strong enough for this application, and it's actually good that it's not too strong. I've crashed in here before while I was trying to set up something and did it wrong, and well, them being 3D printed, these are going to break. I can easily reprint them, and all the other stuff is fine because, well, one of these plastic prints breaking makes a hell of a ruckus, so quickly know to press the E-stop. Now, I have run into a little bit of an issue though, and that is that these bolts that I was using before to hold it in are too long for these ones. These ones had fairly recessed bolts, but they still bottom out before. And well, I could go to the hardware store and get new bolts, but I really don't want to do that. And ordering them would also take a while. So I looked through my bolt collection and I found some M5 bolts that are the correct length that I need. And these ones were M6. M5 is plenty good enough here as well. I just have to replace all of the T-nuts in here. And I only have this many T-nuts here. So I'll let you guess if these are enough T-nuts or not enough T-nuts for all of these spots here. Let's see. And would you look at that? I have exactly this many nuts left. Now, I did cheat a little bit. I did count them beforehand, but still, coincidence that I had exactly 22 of these T-nuts left. So these are all mounted now. I will still have to reteach all of the tool positions, but that will be for later when the spindle is actually mounted again. All right, so what you just saw me do is finish up the greasing of everything. Now I couldn't find the proper adapter for these fittings, so I just got ones with like the regular grease nipple and replaced them. They just barely fit in there. They're kind of on the big side, but it works. That allowed me to grease everything here, and then I also went around and greased everything else to the extent that it is possible with my little foresight to how I'm actually going to do that. But I definitely feel a lot better about everything. Quite a lot of grease fit in there, and like taking off the old fittings here, there was no grease inside of the fittings. So I hope that they had at least some packed into the bearings. But the bearings are still living after a year of using it, so it must have not been too bad. But back to our list here, that allows us to cross this thing off. Now, if you want to see a video where somebody implements a proper greasing concept, go watch any of the scratch build design videos. He is a lot better about this aspect. Now, I think I lost the footage of this, but I also crossed off the point of tightening the belts and bolts. Essentially, that was a non-point. I put that on there just to check, but all the bolts are still tightened, all the belts are also still tight as tight as they were before, so that is good. We've also added an additional tool holder. Just need to probe it in, but that will be really nice having one more. And up here, getting the spindle serviced, that is now also completed. Here we have it. It is back from Spinogy. And it turns out there was actually something significantly wrong with it. I mainly noticed more vibrations, and sometimes I noticed that there might be a little bit less torque. Now, I wasn't sure if I was just imagining that or if that was actually the case, but that was very much actually the case. It turned out that the rotor inside, kind of the glue that attaches it to the shaft, gave away, so it was just held in place by friction, and must have been a pretty tight fit because the friction still allowed it to work perfectly well. But it could just like slightly rotate, and I guess depending on how it landed, it had more vibrations. But that is all fixed now, and I should have a lot more torque again as well. So let's put that back on there, get it trimmed, get all the new positions probed in, and then this machine is back up and running. Here we go. All back and set up. Now I still need to jam it in, and then I'll finally finish tightening this. But this video has already gotten very long, so I will do the rest of this reinstall off camera. There's not that much to see anyhow. And then, well, first of all, let's cross this off here so you get the satisfaction. And then you can see that there are still a number of spots open here, and that will be the topic of a future video. Now, when the spindle was at Spinogy to get serviced, I also asked them to get some more pull studs. This is what is attached here at the top of the tool holders. And the tool holders themselves, they are regular kind of ISO 20 style. Taper is exactly the same, and so you can get ISO 20 tool holders, but the pull stud is unique to the Spinogy spindles. So in order to have more tool holders, I am buying the tool holders themselves from China because they cost a fraction of the price. But the pull studs I did get from Spinogy. I want to give a big thanks at this point. They give me a little bit of a discount on them, as well as repairing the spindle under warranty and taking care of all the shipping back and forth. In case you are looking for a nice ATC spindle, do check out Spinogy. While I did have these little small issues, I think that's just par for the course, and I was unlucky that something gave away. But in general, I'm still super happy with the spindle and would get it again. So with that, I hope you like this kind of random stuff video where I just kind of go through and do some maintenance. If you do, leave a like down below, leave a comment. If you don't, or if you have any suggestions of how I should improve the video, please do leave a comment. Now, if you hate this video, probably not watching anymore, but in case you're masochistic and you did anyhow, well, let me know. So with that said, thank you guys for watching, and until next time.